Okay, good day, grade 10s. I trust that you are well. Today we will be covering trigonometry of 2D shapes. And of course, the specific 2D shape that we are looking at is a right angle triangle. It's a triangle, but specifically the right angled triangle. So if you can recall I believe it was in term 1 where we started off with trigonometry, right? Trigonometry has to do with a right angle triangle. So of course I know that this is a right angle triangle because one angle in the triangle is 90 degrees. Now a triangle, specifically a right angle triangle, has three sides and we can name these three sides. So the side that is opposite the 90-degree angle, which is the longest side of the right angle triangle, that is called the hypotenuse. The hypotenuse. Now, if we look at this right angle triangle, actually, let me name this right angle triangle. Let's call it triangle ABC, where angle B is 90 degrees. So I have angle A and I have angle C that are two acute angles. Of course, these two angles have to be acute in order for this triangle to close off. Remember, the sum of angles of a triangle is 180 degrees. Now, let's refer to one of these angles, either angle A or angle C. So let's look at angle C, and let angle C be theta. Now, we use these Greek letters to represent angles, right? It's very similar to X or to Y or any of the 26 alphabets, but we use these Greek letters to show the angle, like for example, alpha or beta, or theta, which is commonly used. And let this be our angle of reference. So irrespective of which angle I am referring to, the hypotenuse is still AC because it's opposite 90 degrees and it's the longest side of the right angle triangle. So with reference to this angle here, angle C, I'm going to ask myself which side of this triangle is opposite to theta. So let's just trace this here. The side that is opposite is AB. And with reference to theta, we call that the opposite side, or just the opposite, right? And the word adjacent in English means next to. So with reference to theta, the adjacent side would be side BC. So that is what we call the adjacent side. So this is just a quick recap of trigonometry that we dealt with in term 1. And of course, if we were referring to, let's say, angle A, so let's call this alpha, then the side that is opposite to alpha will be BC, and the side that is adjacent, that is very close, that is next to alpha would be AB. So that's quite an interesting point as well. And in term 1, we also looked at the three trig ratios, and we also looked at the reciprocals of those trig ratios. Now, because I am dealing with trigonometry of 2D shapes, let's just quickly recap on the three trig ratios. Let's write that down. We have trig ratios. The first trig ratio we looked at, or one of the first, was sine theta. Now, sine of the angle, you cannot just write sine. It's sine of the angle. So we're referring to theta. Sine of the angle is always the opposite over the hypotenuse, right? Opposite over the hypotenuse. And in our specific example, which side did we say is the opposite with reference to theta? Because that's the angle that we are dealing with, right? So with reference to theta, the opposite would be AB. And again, irrespective of which angle we are dealing with, the hypotenuse will still be AC. So according to my example, it's whatever the length of AB is divided by AC. Then we also looked at cos of an angle. In this case, we're dealing with theta in my example. which is the adjacent over the hypotenuse. Adjacent over the hypotenuse. So in my example, the adjacent side is BC. So it's BC over the hypotenuse side, which is AC. Okay, so that looks good. Then the last trig ratio that we looked at was tan of the angle, tan theta, which is equal to the opposite over the adjacent. And of course, if I have to look at my diagram, at my right angle triangle, I can see that the opposite is AB over the adjacent, which is BC. So this is quite interesting. And the easiest way to recall the three trig ratios is with the abbreviation or the acronym. It's not really a word, but you can just call it SAKATOA. SAKATOA. Right? Meaning sine is opposite over hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. And of course, the reciprocal of sine theta is cosec theta. The reciprocal of cos theta is sec theta. And the reciprocal of tan theta is cot theta. And remember, the reciprocal is basically you swap in the numerator and the denominator. Basically, it's 1 over sine theta, that is cosec theta, 1 over cos theta, that is sec theta, and cot theta is 1 over tan theta. So that was just a quick recap of the trig ratios. And today, what we are going to do is we are going to look at practical examples. Now, this is why I enjoy trigonometry quite a lot. It's because we can look at real world problems and we can apply these trig concepts to find unknown lengths and unknown angles. So what I'm going to do is now I'm going to open the Siavula textbook. So this is the textbook that we are currently making use of. And this is a free online textbook that is quite useful. So this is Siavula. And let's read the example together and then we can discuss it momentarily. So let me, right, okay, so let's read this example. It says, Manla flies a kite on a 17-meter string at an inclination of 63 degrees. Now, an incline is basically an angle that is going up. So there's two types of angles that we are going to look at. We are going to look at the angle of elevation. Angle of elevation means something that you look up, and we are also going to look at something called the angle of depression. Now, when somebody is depressed, your head is usually down, so it's an angle that's looking down. So what we are required to do in this case, we are required to find the height h of the kite above the ground. Okay, so this is the problem that we have, right? It reads, we just read through the problem, so now let's look at the solution. So just to save some time, I already drew the diagram here. But before I continue, I mentioned two very important terms. The first being the angle of elevation. Now, I like the angle of elevation. It's like when somebody is very positive, they have their heads up. So let's say a person is standing here and their head is up, right? So they're looking up to the sky, whatever they may be looking at. Now, the horizontal plane is formed. Imagine this is a nice straight horizontal line, and this is the line that, of course, it's the ray that they are looking up at. It forms this angle here, and that is what we call the angle of elevation, is when you're looking up. But I said the opposite is also true, the angle of depression. So imagine that you are standing on a tall cliff and you're looking down at the sea, right? Or you're looking down at whatever you're looking down at, right? So this is the horizontal straight line. So there's two planes, and the angle that is formed is called the angle of depression. So in this case, we are looking at the angle of elevation, right? We are looking at the angle of elevation. So if I read this question carefully, right, let's go through it. It says Manla flies a kite on a 17-meter string. So this is 17 meters. How do I get rid of? Okay. So imagine that he is, okay, let's do this. Right. So imagine that he is somewhere here and the kite is formed here. So actually the kite should be, this is the line of the kite. So that's the kite and he's holding the kite. So of course he's looking up. There's an angle of elevation of 63 degrees, which they refer to it as the angle of incline. It's an inclination of 63 degrees. So what I can see that is formed is a right angle triangle. And whenever you see a right angle triangle, there's a couple of things that can come to your head. It's the theorem of Pythagoras, which is the hypotenuse squared is equal to the sum of the square of the other two sides. But of course, what we just dealt with a few minutes ago, which is trigonometry, right? The three trigonometric ratios, whether it's sine theta, cos theta, or whatever angle you're dealing with, and tan of the angle, right? So in this right angle triangle, let's first identify the sides of the right angle triangle. The easiest is the side that is opposite the 90 degrees angle, which is the hypotenuse, right? So I'm just going to abbreviate that as HYP. Then the angle that we are referring to, and by the way, you can find this angle here. How can you find this angle here? You can use the sum of angles of a triangle. 180 degrees minus 63 degrees minus 90 degrees will give you this remaining angle. But let's use 63 degrees because it's much simpler. So remember, theta is basically an angle, and they gave us what that angle is. It's 63 degrees. So with reference to 63 degrees, right, this side H will be the opposite. It's opposite to 63 degrees. And this side D will be the adjacent side. Now let's answer question 1. Question 1 reads, what is the height H of the kite above the ground? So there's the ground here, and you have to look at the kite that is above. So we need to find, right? So what we need to do is we need to find H. So we need to involve the opposite, because H is the opposite side of the right angle triangle with reference to 63 degrees. And we also need to use what is given. I'm not going to use the adjacent side because the adjacent side is D, which is an unknown variable. So let's use what we need to find, which is the opposite. And let's use what is given, which is the hypotenuse. The hypotenuse is given. It's 17 meters, right? Again, usually the sketch is given to you, but if it's not, then you can also see that it's written in the question. It's always important to read the statement before you answer the question. The line of the kite is 17 meters. So let's answer question 1 here together, right? I'm using the ratio that involves the opposite and the hypotenuse. And going back to Sakatoa, which trig ratio from the three, right? Let's not deal with the reciprocals for now. Which one of the three trig ratios would we use? We will, of course, use sine, because sine of 63 degrees is equal to the opposite over the hypotenuse. We know the opposite side. Actually, we don't know the opposite side, but we know the variable, which is h, over the hypotenuse, and we know the length of the hypotenuse. It's 17 meters, right? 17 meters. So we can see that sine 63 degrees is equal to the hypotenuse over 17, the opposite over the hypotenuse rather. Now we need to make h the subject of the formula. And when we say we need to make something the subject of the formula, it means that it's a variable that is equal to something. So this is what I have. If you want, you can write this as h over 17 is equal to sine 63 degrees. How can I get rid of this divided by 17? Because h over 17 means h divided by 17. What's the inverse operation of division? It should be multiplication. So to get rid of 17, you need to multiply both sides by 17 over 1, basically 17 over 1. So the 17s divide off one time. I'm left with h. So I have h is equal to 17 times sine 63 degrees. Now, with the use of your calculator, please make sure your calculator is set on degrees, because there's different, just like how when I measure the length of something, it can be in centimeters, it can be in meters. If you're dealing with larger distances, meters and kilometers. Likewise, when it comes to angles, we use degrees, radians, or grads, right? But in high school, we are only dealing with degrees. So just make sure that that small d is darkened on top of your calculator, preferably if you're using a Casio calculator. So now I have 17 times sine 63 degrees. And let's round that off to 2 decimal places. So h is equal to 15.15 meters. That makes sense because I'm pretty sure it cannot be larger than 17. 17 is the longest side of this right angle triangle. Now to find the length of d, you could use the theorem of Pythagoras. You could say that d squared is equal to 17 squared minus 15.15 all squared. That's the theorem of Pythagoras, which is fine, but in maths, I always like to use what is given. The reason being is, let's say a learner, now mistakes are common because we are only human, and sometimes we make mistakes in our calculations, or maybe we miss something in our calculator. We try not to do it, but sometimes it does happen. So I don't really like to use what I calculated in question 1 to help me find question 2. So what I would like to do is I like to use the trig ratios again. So maybe this time I can actually get it correct, right? If I did make a mistake, of course, this is correct. But what I like to do, just to be on the safe side, let's use the trig ratio that represents the adjacent, because d, the variable d is the adjacent, and the hypotenuse, which is given. Remember, we are using what is given. So which trig ratio involves adjacent and hypotenuse? Of course, that will be cosine, the cos of the angle. Now, let me just read the question before I answer it. It says, if Marla's friend Sipo stands directly below the kite, so here is right, where's this pen? Right, so let's say this is Sipo, this is Marla in red, Sipo is in blue, and he is the guy who's standing directly below the kite. So there's a kite here. Calculate the distance d between the two friends. So the distance between these two guys is d. So that's what trig of 2D shapes is all about. It's more practical examples in maths, and it's very fun because you get to apply the trigonometry to real world problems. And hopefully there's times that we can look at videos or maybe even do the actual experiments on ourselves. Now, we said that to find the adjacent, we are going to use the adjacent and the hypotenuse, which is cosine of the angle. So cos 63 degrees is equal to the adjacent over the hypotenuse, which is the variable d over the hypotenuse of 17. So cos of 63 degrees is equal to d over 17. So now let's make d the subject of the formula. What am I going to do? I'm going to multiply both sides by this denominator of 17. So I have 17 times cos 63 degrees. Let's enter that into our calculator. And your final answer should be 7.72, if I'm rounding up to 2 decimal places, meters. So that basically sums up our first example. Now let's look at example 2 very quickly. So let's look at example 2. Right, okay. So as you can see, I have the second question that we will be looking at, a very practical example as well, which is very fun. It reads, the diagram shows a building of unknown height h. So always try to visualize what they're saying. So BT, this length here is h. We start at point B, so we start here at point B and walk 100 meters away from the building to point Q. So let's say you are at this point here, you take a walk and you stop here at point Q. So you walked a distance of 100 meters away from the building. Next, we measure the angle of elevation, and I spoke to you about the angle of elevation. It's basically, if you look up, the angle that's formed between the horizontal line of sight um, to the point that you are actually looking above, that is called the angle of elevation. And in this case, okay, so let me continue reading, of the angle of elevation from the ground to the top of the building. So that is where you're looking from point Q all the way to point T. And you find that the angle is 38.7 degrees, right? Calculate the height of the building, which is h, right, the variable, to the nearest meter, right? Very, very interesting. So a couple of important things. It's always good practice to read. Actually, I think it's necessary to read the statement and not just look at the diagram. Take your time, ask yourself, what is this question asking me to find? Also, another piece of information that learners tend to ignore is that they said correct to the nearest meter. That means you have to round off to the nearest whole meter. Okay. Now, on that note, right, on that note, let us delve into this question. So the first thing I can see is that this is a right angle triangle, and I need to identify the sides of the right angle triangle. The most obvious and the most easiest one is that the angle or the side that is opposite 90 degrees is known as the hypotenuse, right? We can find this angle using sum of angles of triangle, but let's use the angle of elevation. Let's use the 38.7 degrees, right? The side that of this right angle triangle that is opposite to 38.7 degrees is h. So that is the opposite side. We need to find the opposite side. So we need a trig ratio that involves opposite. And lastly, the side that's closest or next to 38.7 degrees is the adjacent side. Now what we're going to do is we're going to ask ourselves, which trig ratio involves opposite? Right, let me get this right. Which trig ratio involves the opposite? And which side are we given? We are given 100 meters, which is the adjacent side. So which trig ratio involves opposite and adjacent? That will be tan, the tangent of the angle. So we're going to say tan of 38.7 degrees is equal to, and I put that in brackets, it's equal to the opposite, which is h, over the over the adjacent, which is 100. And to make h the subject of the formula, I multiply both sides of my equation by 100. H is equal to 100 times tan of 38.7 degrees. So we take our calculator, we enter that, and let's see what we get from there. So I have the distance or the length of 80.12 meters. And because they said correct to the nearest meter, that is approximately 80 meters. Right, okay, let us look at our last example for today, and that has to deal with the angle of elevation and depression. Right, so let's read the question and let's mark our notes on the diagram as well. So it reads, a block of flats is 200 meters away from a cell phone tower. So let's stop there. Let's look at what they mean. So a block of flats, this is the flats, and it's 200 meters away from the cell phone tower. So let's assume that this line CE is the cell phone tower. Okay, so that's very interesting. Someone stands at B. So somebody's standing on top of the building here, right? So somebody's standing on top of the building. They measure the angle from B to the top of the tower, E, so that's the top of the tower, to be 34 degrees. And of course, that's the angle of elevation because this person is looking up. So this is the angle, this is the horizontal line, and they are looking up to the top of the tower, which is at point E. So that is a good point. And that's forming right angle triangle BE, or rather BDE. Thereafter, it goes on to say, they then measure the angle from B to the bottom of the tower C to be 62 degrees. That's what we call the angle of depression, because you're looking down and it's forming the angle of 62 degrees. What is the height of the tower? Correct to the nearest meter, right? Again, very, very interesting. Okay, so let me write on this blank space here. First thing, let's look at, right? Right, so let's first try to find, this is quite an interesting question. Let's first try to find the distance of CD, because CD is the height, or yes, the height of the building, right? The block of flats is CD. Now we are given angle CBD, right? We are given that angle CBD is equal to 62 degrees. That is what we are given. Do we know angle ACB? Yes, it is also equal to 62 degrees. Now, why is that? You might not realize this, but this horizontal line BD, right? Let me actually write that with a darker color. This straight horizontal line BD is parallel to AB. And what do we know about parallel lines? Again, whenever you see parallel lines in any figure, the first thing that should come into your head is fun, right? You learned this in grade 8. The F, if you see a transversal cuts two parallel lines, you know that it forms corresponding angles. And corresponding angles, when the lines are parallel, are equal to each other. Right? If you see a U shape, or you can even rotate that or flip that around, you know that if this angle is X, this is Y. You know that X plus Y is equal to 180 degrees. Co-interior angles are supplementary, right? That is when the transversal cuts parallel lines. And lastly, the N or the Z shape is what we call alternate angles. Specifically, I'm looking at the alternate interior angles. And we know that alternate angles are equal when the lines are parallel. And since BD is parallel to AC, it implies that angle ACB is equal to angle CBD, which is equal to 62 degrees. And what's my reason? It's alternate angles BD parallel to AC. By the way, alternate angles, so when the transversal cuts parallel lines, that is when alternate angles are equal to each other. So let's answer the question. Let's find the length of AB, because this is a rectangle, by the way. So the length of AB will be the same length as CD, right? So we know that BC, if we look at triangle ABC, we can see that BC is the hypotenuse. We can see that with reference to 62 degrees, that AB is the opposite. And lastly, with reference to 62 degrees, AC is the adjacent. So AB is the opposite and AC is the adjacent, right? Now, which trig ratio involves the opposite, because that's the length I wanted to find, right? And also involves the adjacent. That is going to be opposite and adjacent tan. So I'm going to say tan of 62 degrees is equal to the opposite length over the adjacent length, which is equal to the opposite, which let's just call it AB for now, because that is the length AB, over 200. And what we're going to do now is that we are going to make AB the subject of the formula. So how do we do that again? We multiply both sides of the equation by the denominator of 200. So AB is equal to 200 times tan of 62 degrees. Right, you're going to take your calculator and you're going to punch this in. And what do I have? I have that the length of this building is actually 376.15 meters. And by the way, this implies that, or let's not use this implies because it doesn't really implies, but we know that CD is equal to AB, right? Because opposite sides of rectangles are equal, right? This is a rectangle, by the way. We can see that one pair of opposite sides are parallel and the interior angle is 90 degrees. So we have the minimum condition to prove that this is a rectangle. So CD is equal to 376.15 meters, right? Now what we're going to do is we are going to look at the other triangle. We are going to look at triangle BDE. This is a right angle triangle, right? We are going to look at the triangle that we have here, triangle BDE. So if we look at this, B with specifically with the triangle BDE, the side that is opposite the right angle would be BE, so that's the hypotenuse. This length DE with reference to 34 degrees, so the side that is opposite to 34 degrees is of course the opposite, that's DE, and the adjacent side would be BD, that's the adjacent. By the way, do we know the length of BD? Yes. If this is a rectangle, we know that opposite sides of a rectangle are equal. So BD is the same length as AC. So we can even write that down. I always like to write down whatever information that we have. So we know that BD is equal to AC because opposite sides of the rectangle are equal, right? So which implies that BD is also 200 meters, right? Now again, we are looking at triangle BDE and we are going to use the trig ratio that involves, so we need to define DE, the small length here, so that we can add it to CD, so we can find the total length of CE. So we need to find DE. So which trig ratio involves the opposite, and we know this adjacent side is 200 meters because AC is 200 meters. So which side involves opposite and adjacent? And I know that you are saying that that should definitely be tan. So I'll say tan of 34 degrees is equal to the opposite over the adjacent. So I'm going to say tan of 34 degrees is equal to the opposite, which is DE over the adjacent, which is 200. I'm going to make DE the subject of the formula. So again, how do I get rid of the denominator? I multiply both sides by the denominator. So DE is equal to 200 times tan 34 degrees. take my calculator, I just type that in. And what do we have? We have the length of DE, the small part of the right angle triangle BDE, is 134.90 meters. So now let's get out final answers. So what is the length of the cell phone tower, which is basically CE? CE is basically the length of CD plus the length of DE, which is, we just calculated CD, which is 376.15 meters, plus the length of DE, which we just calculated to be 134.90 meters. We can add the two together and we can get the length of this tower, which is, where is this cursor? Right, which is 511.05. And again, the importance of reading the question, they said round off, or rather correct to the nearest meter. So what will that be? That will be approximately 511 meters. And that is the length of this tower. So what we just calculated now was the length of CE, which is 511 meters, approximately, if you correct to the nearest meter. Okay, that is basically trigonometry of 2D shapes. Please go over these questions and practice as many scenarios as possible. Thank you so much for watching, and all the best in your studies.